welcome to this deep dive. Next time you're walking through a massive airport terminal, I want you to look up
Yeah, definitely look up.
because hidden perfectly flush in the ceiling tiles right above you is this like 23-pound, $1,700 block of steel and magnets. Our mission today is unpacking the hidden engineering that secretly shapes your public experiences. Specifically, we're looking at a heavy-hitting piece of commercial audio hardware, the QSC AD-C10T acoustic design loudspeaker.
It really is the ultimate exercise in invisible design. I mean, it is built for the absolute most demanding public spaces, transit stations, high-end retail, loud
Like
restaurants.
you'd never know it's there.
Exactly. It's
Okay.
specifically engineered so you will never even notice it.
It's like putting a massive sports car engine inside a beige minivan, right?
That is a great way to put it, yeah.
Because on the outside, it's completely stealthy. It has this zero-bezel design, a snap-fit magnetic white grille, and you can even take the logo off so it just disappears into the drywall. But underneath that, we are talking 500 watts of peak power,
Right, 500 watts and a maximum volume of 128 decibels.
which is stadium-level loud. I mean, with that much volume, how do they avoid just blowing out your eardrums when you're, quietly ordering a coffee?
Well, the secret is really in the acoustic geometry. To manage all that raw power without making it sound harsh, the engineers use what's called a coaxial formation.
A coaxial formation. Okay, what does that actually look like?
Basically, they take a 1.5-inch high-frequency driver and place it directly inside the center of a large 10-inch woofer.
Oh, wow. So instead of having a tweeter up top and a woofer down below, the high and low sounds are firing from the exact same physical point in the ceiling.
Precisely. That prevents the different sound waves from, fighting each other as they travel down to your ears. But the real heavy lifter here is the 90-degree DMT waveguide.
Right, the DMT, which stands for Directivity Matched Transition.
Yeah, exactly.
I saw that on the spec sheet, but I mean, what does a waveguide actually do in practice?
You can think of it like a highly calculated funnel. It physically shapes the sound waves right as they leave the speaker. So instead of the audio just blasting out and bouncing erratically off the hard floors and windows.
Which sounds terrible in that
Yeah,
airport.
it's the worst.
Yeah.
But the waveguide perfectly controls that dispersion angle. It guarantees this really smooth, uniform frequency response from a deep 68 hertz all the way up to a crisp 20 kilohertz across the entire room.
So it stops those aggressive hotspots.
Yeah.
Like where the music suddenly gets way too loud just because you took 3 steps to the left.
Right. It physically prevents that from happening.
Okay, that makes perfect sense. It steers the acoustic energy so you get a massive wall of sound that feels even everywhere. But wait, I have to push back on the physical reality of this thing. You mentioned earlier it weighs 23 pounds.
Yeah, 23 pounds of steel and ABS plastic.
Right. So how on earth do you safely suspend a heavy vibrating magnet directly over people's heads?
It is a huge engineering challenge for commercial spaces, definitely. To safely handle that load without risking structural failure, it uses this 3 times double-stepped, long-traveled dog-ear blind mount system.
Okay, hold on. Dog-ear blind mount sounds like intense, heavy industry jargon.
Mm-hmm.
What does that actually mean for the person installing it?
I know it sounds complicated, but
No.
it basically means the installer doesn't have to climb up into the rafters above the ceiling. They can just push the heavy speaker up through the hole from below, so working blind.
Ah, I see.
And then these built-in clamps, the dog ears, swing out and bite down securely onto the ceiling structure itself. Plus, it carries crucial UL 1480 and UL 2043 safety certifications.
Which means it meets strict environmental and fire safety codes, right?
Exactly. It proves it won't act as a hazard in a commercial building.
So it's incredibly secure. But here's another puzzle for you. How does this exact same speaker model work perfectly in a tiny, intimate cafe and a sprawling, mile-long airport concourse?
Well, that comes down to electrical adaptability. It features a 70 and 100-volt multi-tap transformer. Okay. Think of audio signal in massive spaces, like water pressure in a really long pipe. If you just hook up regular speakers in a massive daisy chain, the last speaker in the terminal is going to sound incredibly weak and muffled.
Because you lose all the pressure over that massive distance.
You got it. A 70-volt system keeps that electrical pressure high enough so the speaker at gate 50 sounds just as vibrant as the one at gate 1.
That's brilliant.
Yeah, but if you're installing it in a small, intimate restaurant, you can completely bypass that transformer for a standard 8-ohm system, so it scales effortlessly.
Man, true high-fidelity commercial audio really is a massive balancing act, isn't it? You need extreme power to fill the space, the physical acoustics to make it sound perfectly even, and a stealthy, footprint so it doesn't ruin the room's aesthetics.
It is a lot to ask of one piece of hardware.
Absolutely. And because commercial infrastructure is such a massive investment, HDTVSupply actually backs this QSC unit with a standard 3-year warranty, which bumps up to 6 years if you register it.
It truly is just brilliant engineering hiding right in plain sight.
It really is.
Yeah.
And, it leaves you with something to ponder the next time you're out. If diverse environments, from quiet, dimly lit restaurants to chaotic, sprawling train stations, are utilizing the exact same hidden hardware for their audio, how much of our emotional experience in these public spaces is being secretly engineered by background infrastructure we can't even see?